Welcome to my tutoring session in chemistry. The current video is part 2 in the paper chromatographic series. In this video, I'll explain the different parameters used in paper chromatographic method for carrying out the qualitative analysis. They are RF value, RX value and RM values. This will be followed by explanation about different types of paper chromatographic methods. They are ascending paper chromatographic method, descending paper method, ascending descending type, circular paper chromatography and two-dimensional paper chromatographic method. Let me begin the video with the most important parameter used in paper chromatography for carrying out the qualitative analysis. RF is the abbreviation for retardation factor or retention factor. RF value is used for qualitative analysis, that is for identification of the given sample or a compound. And the RF value is constant for the given sample or a chemical compound, and it is a constant value for a given combination of stationary and mobile phase. We have run a paper chromatography for the sample aspirin labeled as A, and the RF value was found to be 0.5. How do you calculate the RF value and what are the requirements for calculating the RF value? So baseline is required. The distance traveled by the compound that is separated in the paper chromatographic experiment and the distance traveled by the solvent front. Now, these three are very much required for calculating the RF value for the given organic compound. Now here in this case, the distance traveled by the compound aspirin is X, while the distance traveled by the solvent front from the baseline is found to be Y. Now you can calculate the RF value for the compound aspirin by dividing the distance traveled by aspirin from the baseline divided by the distance traveled by the solvent from the baseline. Now the RF value ranges from 0 to 1 and the ideal RF value would be somewhere around 0.3 to 0.8. Now here in this particular experimentation, RF value is equal to X by Y, that is equal to 0.5, that is for aspirin. So you need a stationary phase and a mobile phase for carrying out the separation by paper chromatographic method. Stationary phase is the moisture or a water layer that is adsorbed on the or over the cellulose layers in the parchment paper, and mobile phase is the solvent that is used for the separation. Now I have not mentioned the solvent system because the RF value, it varies with the particular solvent system. Say for example, if you are using 9:1 ratio of hexane to ethyl acetate, the RF value will be different with that of 5:5 ratio of ethyl acetate and hexane. So RF value is constant for a given combination of stationary and mobile phase. So when you are trying to compare the RF values for a standard compound, so make sure that you compare the mobile phases, the combination of mobile phase that is used for that particular separation. Because as I already mentioned, RF value is constant for a given combination of stationary and mobile phase, and RF value, it varies with the mobile phase that is used for the separation. So make sure that the solvent system that you have selected is such that the RF value is somewhere around 0.4 to 0.5. So the ideal value will be somewhere around 0.4 to 0.5. And the mobile phase should be selected in that particular manner where the RF value ends somewhere between 0.3 to 0.5. Now moving on to the next parameter used for qualitative analysis, that is Rx value. Now the Rx value is always 1. It should be 1. And how do you calculate the Rx value? Rx value is calculated by dividing the distance traveled by the sample by the distance traveled by the standard. And the value should be always 1. That is when the sample and standard, when they are both same, you end up with 1. If you don't end up with value of 1, then your sample is totally different from that of the standard. Let's say you are synthesizing or you have synthesized aspirin in the laboratory using salicylic acid, acetic anhydride and catalytic amounts of concentrated sulfuric acid. When you reflex salicylic acid with acetic anhydride with few drops of sulfuric acid added, that acts as a catalyst. After a reflexing period of 30 minutes, you cool the reaction mixture and pour into ice cold water with constant stirring or mixture, whereupon the aspirin, it precipitates or separates as a solid, that is filtered and washed with water. So wash with copious amounts of ice cold water in order to remove the excess of unreacted sulfuric acid. Now let's check whether the synthesized compound is aspirin or not, or whether we have got the desired product that you are synthesized in the laboratory, that is aspirin. So run the paper chromatography, and when you're doing that, you need to run the synthesized sample of aspirin along with the standard sample of aspirin. And we see that the standard sample of aspirin that is used for comparison purpose, it has traveled a certain distance, and the synthesized product, the product aspirin that is synthesized in the laboratory, it also travels the same distance, and therefore the Rx value is found to be 1, because the distance traveled by the standard sample of aspirin as well as the aspirin sample that is synthesized in the laboratory, they travel the same distance, and therefore the Rx value is found to be 1. But in addition to the synthesized product spot, we find an additional spot at the lower end of the Wattman paper, slightly above the baseline, and this was found to be an impurity spot, the unreacted salicylic acid. So some amount or trace amounts of salicylic acid was left unreacted, and that has shown up in the paper chromatography as a impurity spot. So Rx value for the synthesized aspirin was found to be 1, whereas the Rx value for the impurity spot was found to be salicylic acid, was found to be 0.33. So Rx value for the impurity spot of salicylic acid was found to be 0.33. So using the Rx value, two things can be done here. One is identification of the synthesized aspirin, and second is identifying the impurities, that is assessing the purity of the compound. So you can not only identify the synthesized compound by Rx value by comparing with the standard spot, at the same time you can also assess the purity of the compound. So if you get any impurity spot, then it clearly states that the product is not pure, and therefore you have to recrystallize the aspirin sample that is being synthesized in the laboratory by recrystallization. And after purification of the impure product that you have synthesized, you can again run the sample and make sure this time the impurity spot doesn't show up in the paper chromatography. And that's about Rx value. Now moving on to the Rm value. Now RF values of chemically related compounds are very close. Like for example, there are compounds with functional group OH covalently bond to the aromatic ring, and they are categorized or classified as phenols. In case of aldehydes, you find the functional group CHO. Now say for example, you have given three compounds, orthocresol, metacresol and paracresol. The molecular weight and the molecular composition of all the three compounds is one and the same. Only difference is that the position of the OH group on the aromatic ring, it varies. In case of orthocresol, the OH group is at the second position. In case of metacresol, it is at the third position. And in case of paracresol, it is at the fourth position. So orthocresol, metacresol and paracresol, they are chemically related compounds. And therefore, we can expect their RF values to be very close. So how do you assess this chemical related compounds? By making use of the Rm value. Now Rm values are, that is delta Rm values are constant for the compounds that belong to the homologous series, like in case of orthocresol, metacresol and paracresol. And Rm value can be calculated using the formula log into 1 upon Rf minus 1. So you know how to calculate the Rf value. Just plug in the values and calculate the Rm values for the given series of compounds that are chemically related. And finally, when the delta Rm values are constant, then you can conclude or come to the conclusion that the given series of compounds, they belong to the homologous series. So much for the parameters involved in paper chromatography for carrying out the qualitative analysis. Now moving on to the different types of paper chromatographic methods. They are ascending type, descending type, ascending descending type, circular paper chromatographic method and 2D paper chromatographic method. Let me walk you through these 5 methods in sequential order. To begin with, ascending paper chromatographic method. So you draw a baseline at the lower end of the Batman paper, apply the spot, dry the spot and run the paper. And in ascending paper chromatographic method, the mobile phase, it flows to the Batman paper by capillary action, and the mobile phase, it flows against gravity, and hence the name ascending paper. So the name ascending is given based on the direction of the flow of the mobile phase. Now here the arrow indicates the direction of development or the direction in which the mobile phase flows, and hence the name ascending paper chromatographic method. And with the flow of the mobile phase, the sample applied on the baseline, it gets separated and it travels a particular distance depending on nature of its polarity. Now second method is the descending paper chromatographic method. It is exactly opposite to that of the ascending paper chromatographic method. So the meaning of descending is to come down. Now here in descending paper chromatographic method, the Vatman paper is held by a siphon glass rod, or it is clipped, or even a thread can also be used to hang the Vatman paper. And a trough containing the mobile phase or the solvent is placed at the top of the Vatman paper, and the mobile phase, it flows through the Vatman paper by capillary action. Now this time the mobile phase, it flows down by capillary action assisted by gravity. So in case of ascending type, the mobile phase, it flows against gravity, while in case of descending technique or descending method, you find that the mobile phase is flowing with gravity, and therefore the separation is faster in case of descending technique, while in case of ascending technique, as the mobile phase is flowing through the paper against gravity, the separation is faster. So time taken for separation is less in case of descending as compared to ascending technique. Now ascending descending type chromatography, it is a combination of both the techniques, previous two techniques, that is ascending and descending. And in case of ascending descending type paper chromatographic method, so initially the solvent flows upwards by capillary action, and later it flows down. So first half of the experimentation, it follows the ascending principle, while the second half of this operation, it follows the descending technique. So ascending descending type is a combination of the ascending and descending paper chromatographic method. So the advantage in case of ascending descending type technique is that the length of the separation can be increased. In case of circular paper chromatographic method, you take a circular Wattman paper, and these circular papers are commercially available. You make a hole at the center of the circular Wattman paper. You draw a baseline around this hole that you have made at the center, and on this baseline you make reference marking. You mark spots on the baseline, and this will be the reference spots for the 4 different sample mixtures that has to be applied. And you can label all the 4 different reference spots that you have marked on the baseline, and later apply the sample using a microsyringe or micropipette, or even a capillary can also be used, and later dry the spot. And meanwhile you can prepare the chromatographic chamber. You can take a petri plate of suitable dimension, fill the petri plate with the mobile phase, cover the petri plate, and set it aside for saturation. So this may take around 5 to 10 minutes. So meanwhile, you can prepare a wick using a thread or a Wattman paper, roll it up and pass it through the hole that you have made at the center of the Wattman paper. So even a cotton wool can also be used for preparing the wick. Now place the prepared Wattman paper along with the wick in the petri plate, and make sure when you are introducing the Wattman paper, the lower end of the wick, it immerses into the mobile phase, and by capillary action, and then you can close the petri plate, and by capillary action, the mobile phase, that is a solvent, it travels up the wick, and when the solvent touches the circular Wattman paper, the solvent flows uniformly in all the directions. There is a uniform flow, and along with the flow of the mobile phase in all the directions, the separation of the 4 sample mixtures applied on the baseline A, B, C and D, they get separated into individual components. Now the advantage with the circular paper chromatographic method is that more number of sample mixtures can be applied on the baseline. Now moving on to the interesting method, that is 2-dimensional paper chromatographic method. So how do you carry out this method? You cut the sheet of Wattman paper in a suitable dimension as per the requirement. You draw two margin lines and apply the sample where these two margin lines intersect. So the sample mixture is applied where the two margin lines that you have drawn intersect. Now the arrow indicates the direction of development. Now the paper is developed in one direction using a particular solvent, say solvent 1, and then later the paper is developed in a second direction using a second solvent. So we begin with the first solvent and the arrow indicates the direction of development. So after the separation is done, we see that the given sample mixture is separated into 3 individual components highlighted by red, blue and green colors. Now dry the Wattman paper, the developed Wattman paper, and after drying it, you rotate or turn the Wattman paper at right angles at around 90 degrees. So after the rotation is done, you again run the Wattman paper with the second solvent in a second direction. And remember, the arrow indicates the direction of development. And after the separation is done, we see that these 3 spots again get separated into 3 individual components. And this will be the final separation. So finally, we see that the given sample is a multi-component mixture comprising of 9 amino acids. And the advantage with the two-dimensional paper chromatographic method is that the complex mixtures can be separated into individual components by the two-dimensional method. So here you can see that the given sample mixture highlighted in yellow, they are separated into 9 individual components. And amino acids, when they are separated by paper chromatographic method, they are colorless, and when you spray with the neodymium reagent, they appear as purple colored spots. So in the two-dimensional paper chromatographic method, the paper is developed in one direction with the first solvent, and later the paper is developed in the second direction. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.